All right, stay put. So I'm going to do 5 to do today. So what this one consists of is verifying trig identities, right? So you'll have like da 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 equals blah da da da, right? And so if you accidentally so, and eventually 5-3 we get into equations like, and you want to get it down to something like this, right? And so we're simplifying equations down to, this is a preview of the next section more, but here we're going to do, to verify trigs, there's a kind of a 4-step process. First, work one side, right, at a time. Maybe start with the complicated side and try to condense it down to something more simple, something that looks more recognizable. 2, seek opportunities to factor, add, subtract, anything to try to get a monomial denominator. Right, the purpose of getting a monomial denominator is I can separate it. Like if I have 1 over x minus 2, that does absolutely not equal 1 over x minus 1 over 2, right? Bad algebra right there, okay? But if I have x over x minus 2 over x, that does equal x over x minus 2 over x, correct? And so then I go, oh, well that is 1 minus 2 over x, and then I can go ahead and start solving that way, okay? So that's kind of what we try to do when we're verifying trig identities. Number 3, if you can convert things to the trig functions we know best. What are the trig functions we know best? What's the ones that are most familiar to you guys? Yeah, exactly. Sine, cosine, and even tangent, right? And lastly, because there's no exact right way to verify a trig, you can kind of play around a little bit, okay, and see what you can get to, see what you can do. So, an example here. Secant squared theta minus 1 over secant squared theta equals sine squared theta. Okay, we're going to try to verify that.
What's step 4? It says just play?
Yeah, just play. Just so I erased it. Remember those 4 trig functions I had before, right? Sine squared plus cosine squared is 1.
Yeah.
What are the other ones?
1 plus like
Tangent squared.
theta equals cosine or something like that.
We have a secant squared theta.
I have
Tangent squared theta plus 1 is secant. We actually have that.
What plus cotangent squared is like cosecant squared?
Oh, yep, 1 plus cotangent squared is cosecant. So 1 tangent squared plus 1 is secant, and 1 plus cotangent squared is cosecant squared theta. And so from these plus the sine squared, right, from those 3 you can derive all 6, right? I can solve for sine, I can solve for cosine, I can solve for secant, tangent, cotangent, cosecant, right? So I can solve for all 6 trig functions, all 6 squared trig functions, and for the trig functions as well, right? Good. So you have this available to you. And again, you can rewrite all 6 of them on here if you want. So, okay, what do I have? Do I have anything that looks familiar here? Secant squared theta minus 1. What is that? I look here. both sides?
Yes.
So secant squared theta minus 1 is tangent squared. Okay, so let me rewrite this. So the top here is tangent squared theta. What is secant squared theta, by the way?
What is what?
Secant?
1 over cosine.
Cosine? And so 1 over secant squared theta is actually cosine squared theta, right? So this secant squared minus 1 is actually tangent squared. And then 1 over secant squared theta is actually cosine squared theta, right? And that's sine squared theta on the right side. And so what is tangent squared? Tangent is
Isn't it still tangent squared over secant squared and then?
yes, but we did 1 over secant. This is 1 over secant squared, right?
Oh, so you just got 1
And-
and then cosine squared.
Yeah. So 1 over cosine squared theta is secant squared, and 1 over secant squared theta is cosine squared theta, right?
Yeah.
Just the inverse. And so this here is 1 over secant squared theta times quantity secant squared theta minus 1, right? So I could rewrite this 1 over like that, right? And so 1 over secant squared theta is actually cosine squared theta. And secant squared theta minus 1 is tangent squared theta, right? Okay, and then tangent squared theta is sine squared theta over cosine squared theta.
And it like all cancels out.
Yeah, exactly, right? So I've got cosine squared over cosine squared. And what am I left with? Sine squared theta, sine squared theta, right? And so I verified that using just one of those trig things there, right? And just kind of definitions and, okay? All right. So any questions on that? Let's do another one. Everybody good? Everybody set? So I have got my YouTube channel up.
Did your first class get canceled?
No, but we had 4 out of 6.
That's what I thought. It's so weird. Like every school around us is canceled. These like Catholics canceled, and other universities on break, but Central's like.
They canceled the last second, and
Yeah.
so
I
it
know
was.
they didn't send it till like late last night. I was like, there's no way we're having school. I was really sad.
I mean, I was kind of I'm glad we got out of the house. But
Yeah, well, this is the worst thing. It
Yeah, I
does
know.
suck because, hey, no work, no school, and I can't go anywhere.
It sucks in the snow.
I'm sure you guys enjoyed it for a few minutes.
Oh, you're making your file today.
Okay. All right, guys. So help me out here.
Okay, we'll help you out. So,
There's by the way, you can do this more than one way, right? First off, what do you want to do here first?
can we pull the sine squared out from the one side?
From this side?
Yeah.
And so you get what, 1 minus,
Sine squared theta times sine
well,
minus sine squared theta?
yeah, because this would be
Oh,
2,
I see,
right?
yeah.
So this would be like plus. Yeah.
Okay, yeah, I see.
So yeah, okay,
And
that's a
then
good
you
start.
can convert one of them into
1 minus sine squared theta is cosine squared theta. And on the left side, I get cosine squared theta minus sine squared theta is cosine squared theta minus sine squared theta. Good, right? It's true. Done. So good. Everybody see that? Another way you could have done is left this. You could have subtracted 1 from both sides, and I have cosine squared theta minus 1, which is sine squared theta. Sine squared theta minus sine squared theta is minus 2 sine. So yeah, that would have worked too,
So you could,
right?
you can't just like add sine squared theta to the right side, so it would be 1 minus.
You could
sine?
do, yep, you could do that.
Oh, okay.
You could do that. So if I do that, I go plus sine squared theta plus theta, and then I have cosine squared theta equals 1 minus sine squared theta, right? Which according to my trig function is true. So that's another way to do it, right? So this is why I'm saying you just play around a little bit. There are many ways to go through this, right? Okay. Number 6. All right, number 6 says oh, that was number 5. Cosine squared theta minus I think I just sorted just did that. Let me not do that one again. Let's do number 8. Cosine x plus sine x tan x equals secant x. Okay? All right? Verify that. All right, so what can you do? What do you guys think?
Can you separate the tan from the sine? Like, are you able to do that?
Well, I can.
Could you divide both sides by tan? Because then you get
I
1
could do
over
that.
1 side.
I could. You want to divide the whole thing by tangent or
Yeah, 'cause
by?
then it works because cosine plus sine x equals 1.
Yeah, and then you can.
Okay, so let me rewrite this as. So that it makes more sense, right?
Oh.
And then this is 1 over cosine x. Okay, so now you want to.
Can you multiply both sides by cosine then?
Yeah, so let's multiply everything by cosine.
Okay.
Right? That sounds good. And then I'm gonna, so if I multiply cosine x, and this is gonna be 1. What's on the left side? Cosine squared x plus sine squared x. Is that true? Cosine squared x plus sine squared x is 1. Yeah, there you go. Just 2 quick steps, right? So number 1, I turned tangent into sine over cosine. Remember that was like tip number 3, I think, right? And I turned secant into 1 over cosine. So now I have everything in sine and cosine. And you get everything in similar, like sine and cosine, it should get easier from there, right? Because those are the 2 main ones that we learned, right? Tangent, sine, cosine, tangent. You get everything in sine, cosine, tangent, you have everything in sine and cosine. And from there, you can try to derive more basic things, right? So that was pretty quick, actually. So like you said, turn this into a sine over cosine, and then I have a denominator of cosine, cosine. Oh, if my denominators are all common, what do? Multiply everything by that denominator, right? And that gets rid of my denominator. Okay? Okay. I got a better pen in my bag. It's terrible. Oh, here we go. I always try to carry one good pen. But usually I leave them in the classroom, so. Secant theta minus 1 over 1 minus cosine theta equals secant theta. All right. All right, you guys, want to get started on that?
Yes.
On this bad boy? Okay, so first of all,
Tangent theta's on the top.
not quite, right?
Why
Because
not?
tangent is squared.
Oh.
Okay.
Never mind, I lied.
So, but what I do see on the bottom is I see 1.
It's sine squared. Oh, wait, it's not squared either.
Not that, but on the I can get it into a squared. I need a squared, right? Because those things are all in terms of squared.
Can you
Is
do
it
where
just
the
square?
way?
So I can turn this into a difference of squares by,
Plus,
I don't want to square the whole thing, but I want to do almost that.
plus cosine minus cosine.
1 plus cosine, yeah.
Oh, multiply?
Basically I'm multiplying by 1, right?
Yeah.
So I want to multiply by the difference. So this is 1 minus cosine theta, so I'm going to multiply by 1 plus cosine theta, right? Over itself. So this is just 1. And what I'm left with is 1 plus cosine theta times, what is secant, by the way?
Secant is 1 over cosine.
1 over cosine, so let's think of that 1 over cosine theta minus 1, okay? And then on bottom, I've got 1 minus cosine squared theta. Okay, that's cool, right?
The bottom is the same as sine squared, right?
Yeah. So basically this bottom is just sine squared theta. Right, everybody see that? And on the right, what is this?
1 over cosine theta.
Okay, so let's go ahead and multiply this out. We have 1, left, I'm going to get 1 over cosine theta, which is, well, let's leave that, maybe we should just leave that as secant theta, right? Well, okay, 1 over cosine theta minus 1 times cosine times 1 over cosine is 1. So minus 1 plus 1, and then minus cosine theta. And that's over sine squared theta.
Is this gonna add me to
Okay? So basically these go away, right? 1 over cosine theta minus cosine theta. Okay, now I'm gonna, what if I multiply both sides by cosine theta? Get rid of this? Okay? So then I'm gonna get cosine theta times 1 over cosine theta, which is 1, minus cosine times cosine,
cosine squared?
over sine squared theta equals 1. What is this on top?
This could be sine.
Sine squared theta over sine squared theta is 1, right? It's good.
Good job, guys.
Thanks for all your help. Natalie. Anyways. Okay? So isn't this fun? It's like creative and takes a little bit of thinking, right?
Yeah.
Alright, so now I'm gonna have to move my camera. You just move my camera here, right? Oh my god, I wasn't recording. Okay, so we're going to play with this one now. Okay? So what should we do with this? What did I do with the last one? Yeah. Well, this is plus, so 1 minus. There you go. So this here is just 1, right? This is just 1. And it's the opposite of this. Okay? So I'm left with 1 minus over, and this is going to be 1 minus cosecant squared theta, right? So look at your chart. What is 1 minus cosecant squared theta? Is it anything, actually?
Yeah, well,
I don't think it.
oh no, it's not. It's negative.
Negative cotangent, right?
Because you're just like.
So this, yeah. Okay, so this part is negative cotangent, so I'm going to get 1 minus, what is this? This is cosecant. Cosecant theta times cotangent squared theta over a negative cotangent squared theta, right? So those are going to cancel out. Okay.
Isn't it negative sign? Why did the negative go away?
Negative's still here.